In the ionization constant of weak acid lab, we are going to perform a series of experiments in order to determine what the ionization constant of unknown weak acid is, and then you're going to try to determine which acid you think it might be. So, let's talk through what you're going to do here. If you look at your lab handout, it walks you through how we come up with the Henderson-Hasselbalch equation. So I'm not going to walk through that because your lab handout is pretty thorough already on that. What I want to get into is we need to talk about how to use the pH meter in this experiment. So I'm going to go through the steps of how you set up your pH meter using the lab class. And make sure that you write these down because you will need them again in the next couple of labs. So once you plug in your pH meter into the lab class, you're going to go to, this is not one to write. You're going to go to Sensors, and you're going to click on Calibrate. And you're going to, once you click on Calibrate, you're going to press Calibrate now. And then you're going to have two pH buffers available to you. One of them will be pH 4 and one of them will be pH 7. So you're going to place your pH electrode in the pH 7 buffer. Sorry, in the pH 4 buffer rather. So you're going to go to Sensors, Calibrate, select Calibrate now, and you're going to put your pH electrode in the pH 4 buffer. Once you do that, you're going to see a number on the LabQuest screen called the relative stability reference. You're going to wait for that number to stabilize. So the relative stability reference is what LabQuest calls the number that they use to measure the voltage. And you want to let that stabilize so that when you put in that this is pH 4, then you are sure that what you are measuring is the pH 4 buffer. If that's still changing, then you may be telling it something is pH 4 when it's actually not. So you want to wait for that relative stability reference to stabilize. And then once it stabilizes, you're going to type in 4. And then after you type in 4, you're going to select Keep. So now you have just told the LabQuest that the solution that you put your pH electrode in is a pH 4 buffer. So now you're going to take your pH probe out, and you're going to rinse the pH probe with DI water. And you're going to dry it with a chem wipe, and you want to be gentle with it because these pH electrodes are very fragile and very sensitive, so it is easy to break them. So you're going to rinse your pH probe off with your DI water, and then you're going to gently dry it off with a chem wipe, and then you're going to place your pH electrode in the pH 7 buffer. And again, you're going to wait for that relative stability reference to stabilize. Because if it doesn't stabilize this time, then what's going to happen is you essentially will have just told it that there is no difference between a pH 4 and a pH 7 buffer. And that's going to really mess with your measurements when you try to measure the pH of your solutions. So make sure that this value is stabilized, and it may take a few seconds or even a minute, so be patient. Allow that number to stabilize, and then once that number stabilizes, you're going to type in 7, and then you're going to select apply. So now you have calibrated your pH meter. So now we have taken solutions that we know for sure are pH 4 and pH 7 because they are buffer solutions, and we've made sure that they're going to maintain those pHs. And you've now calibrated, you've put your pH meter, your pH probe into the pH 4 and pH 7 and let your device know that those are the references. So now, as long as you are measuring within those values or not too far outside of those values, then you will be fine. Your pH should be relatively accurate. So once you do that, you're going to measure 0.10 molar solution of one of the weak acids, and there will probably only be one out, but you're going to get 50 milliliters of one of those weak acids, and you're going to set up your solution. So you will be putting the solution to a magnetic stir and keeping it running. Make sure that your magnetic stir bar does not hit the pH probe, because as I said, the pH probe is very fragile and it's sensitive. So if you let that stir bar hit your pH electrode, it can break it, and then it's not going to work properly anymore. So then you're going to do several experiments where you add 5 milliliters of the 0.10 molar solution of the sodium salt, which is the conjugate base of your weak acid, and you're going to see what happens to the pH. So let's walk through the calculations that you will need to do. So in the first column here, if you look at your report sheet, you have your volume of your weak acid and your volume of A negative. And then you are given the total volume of your solution. So you need to calculate your concentrations of your your weak acid. So we're going to use our good old friend M1V1 equals M2V2. So this expression should sound very familiar to you. So we need to calculate the concentration of A negative and HA. So I'm going to do this for trial 1, and then I'm going to have you work through trial 2 through 6 on your own. So for trial 1, we're going to have for A negative, we added 5 milliliters of our A negative, and we started with a concentration of 0.10 molar. And then we diluted this to a total volume of 55 milliliters. So M2, if I rearrange this algebraically, equals 0.10 molar. So that's 5 milliliters. So I don't know where 0.05 came from. So we have 0.10 molar, and we took 5 milliliters of that, and we diluted it to a volume of 55 milliliters. So put this into your calculator. We have 0.10 molar times times 5 milliliters divided by 55, and you should come up with times 5, divide that by 55, and we are rounding to two significant figures. So we would have 0.0091 molar for your concentration of A negative. Then for HA, you're going to take 0.10 molar, and we added 50 milliliters of that. That's equal to M2, and we had a total volume of 55 milliliters. So M2, if I rearrange this algebraically, equals 0.10 molar times 50 milliliters divided by 55 milliliters. And if we plug that into the calculator, we get 0.091 molar. So I'm going to have you do this. Calculate your concentrations for trials 2 through 6. But let's go ahead and talk about what you need to do, what else you need to do in your table. So you're going to calculate A negative over HA. So for example, in this case, we're going to take the numbers that we came up with, 0.0091 divided by 0.091, and don't use the rounded values. Make sure that you store the numbers in your calculator and use the actual value, not the value that you rounded off. So if we divide this, we get 0.1. And then in column 8 on your report sheet, you're going to take the log of A negative over HA. Which is the log of 0.1. So if I take the log of 0.1, I get -1. Then you will have recorded your pH when you created this solution and stirred it. So then what you're going to do is remember our Henderson-Hasselbalch equation. pKa equals pH minus the log of A negative over HA. So you're going to take your pH minus a -1, and that's going to give you the pKa. So you're going to do this for all 6 trials, and then you're going to take your average pKa, so you're going to add up the pKa you got for each trial and divide by 6 to get your average pKa, and then you're going to calculate your average Ka. So remember, Ka is 10 to the negative pKa. So whatever you got for your average pKa, you're going to take 10 to the negative of that and get an average Ka. Once you do that, you are then going to complete the discussion question. So you're going to look up the 3 Ka values of the weak acids used in this experiment in your book. And you're actually only going to use one, but I'm going to have you look up 3. And the 3 that I'm going to have you look up are oxalic acid, nitrous acid, and hydrofluoric acid. Actually, let's not do hydrofluoric acid. Let's do acetic acid. So you're going to do oxalic acid, nitrous acid, and acetic acid. You're going to look up the Kas of those weak acids, and you're going to report those in your lab notebook. And then you're going to see which one you think is your acid. And you're also going to tell me which one would give you the highest H3O plus concentration. So that is what you're going to do for the ionization constant of a weak acid lab. So make sure you have submitted your purpose and procedure on Canvas, and I will see you in lab.